Okay, so picking back up in lesson 6-7 for the day, hopefully finishing up, and we may skip a few examples here and there based on what I have written in my notes. Finding an inverse, okay, kind of have 3 steps in a way. No, 2 steps. I'd say 2 steps. Third, I guess, if you want to talk about how to notate at the end. So if you look at A, step 1, I even have it written in there, was to switch X and Y. So when we talk about switching X and Y, if it currently says Y equals 2X plus 8, what's it going to read when I switch X and Y? Not exactly. Just the X and Y.
I said X equals 2Y plus 8.
Okay, X equals 2Y plus 8. Leave any numbers, symbols, etc. where they are. It's just literally the variable. So instead of Y equals, I'm going to say X equals. Instead of 2X then, it's 2Y plus 8. Okay? So that's your step 1. You're switching X and Y. What's step 2?
Subtract.
Okay, subtract the 8 because my ultimate goal is to solve for Y. We want to make it Y equals. So if I'm trying to get Y by itself, if it's 2Y plus 8, subtract 8. If I subtract 8 from one side, subtract 8 from the other side, X minus 8 is X minus 8. On the other side, my 8 minus 8 cancel, and I'm left with 2Y. Now, at some point, you may want to flip-flop your sides. Whether you do it on this step or the next step is up to you. Do you understand what I mean when I say flip-flop your sides? So for me, instead of writing X minus 8, can you handle it if I go ahead and write 2Y equals X minus 8? Instead of X minus 8 equals 2Y? Okay. Is Y by itself? Okay, not yet. I need to divide by 2. You divide the left by 2, you divide the right by 2. So we end up with, okay, and I'm flexible. Is Math Excel flexible? I think they might be flexible on this one, but it's hard for me to answer. So Eli gave this as X minus 8 over 2. I agree. Based on the fact I next want to talk about whether or not it's a function, what's the other option of how I can write this? That 2 will do what? It will divide into both pieces. And so if you think about that, X divided by 2 is X divided by 2 minus 8 divided by 2 is 4. And no, I did not say X minus 8 over 2 is wrong. That's equivalent as well. Now, officially, those are our 2 steps. If you want a step 3, let's write it with proper notation now that we have it Y equals. What do I mean proper notation? Yeah, write it with the F inverse notation. So replace the Y with F inverse of X equals X over 2 minus 4, or X minus 8 all over 2. Okay. Now, I want to be able to talk about, is this a function? So before we move on, we're going to talk about, is it a function? A helpful way to think about whether it's a function is to first think about what the original item was. What was my original Y equals 2X plus 8? Can you visualize what Y equals 2X plus 8 is a graph of? You should be able to. Yeah, that's Y equals mx plus b form, yes? So it is a line with an intercept of 8 that it has a slope of 2. So up 2 over 1, up 2 over 1. So with that in mind, if that's a line, what is it when I reflect it? If you recall, we talked about it reflects over the Y equals X line. What is a line when I reflect it over something? It's still a line, yes? It's just going to change the direction it's going. So if I take that line, I reflect it, it doesn't even really matter how I reflect it, it's still going to be a line. So, and in this case, I think it just becomes, well, you can look right here. This time it's going to have a slope, or a y-intercept of -4, and a slope of 1/2. So instead of up 2 over 1, should have made that steeper. It's now going to be up 1 over 2. Is that a function?
Yes.
Why yes? Okay, so I heard two things. First of all, if we think physically at the graph, does it pass the vertical line test? Can I draw a vertical line that just touches the graph once?
Yes.
Yeah, any place to draw a vertical line is just going to touch the graph once. Or think about it. Are there any x's that I can put in here that are going to give me two different y's? No. About the only time you're going to see that happen is if there's like a plus or minus in front of it. Thus, remember right here, it wasn't a function. That was because of that plus or minus. I could put x in and get two different values out. So this one is a function. Okay. Let's try C. You got the steps down? Step 1? Swap. I'll go for that. So if it says y equals square root of x minus 2, instead of y, I'm going to say x. Instead of square root of x minus 2, square root of y minus 2. Step 2. Okay. Isolate the y. Solve for y. What do I need to move to get y by itself? The 2. But I can't move that 2 until the radical is gone. How do I get rid of a square root? Square it, right? If you have a square root, you're going to square it. So if I square the square root, that means I also have to square the other side, right? We're squaring both sides. What is the square root of y minus 2 squared? Y minus 2. When you square square root, you get what's ever under the radical. What is x when you square it? X squared. So what's the equation I have at this point? Okay. X squared equals y minus 2. Or if you flip it, y minus 2 equals x squared. Is y isolated? No. How do I finish solving for y? It's y minus 2. Let's add 2. I now have y equals x squared plus 2. Proper notation. F inverse of x equals x squared plus 2. Okay. Any thoughts on whether that inverse is a function? You can try and visualize that graph, because I'm going to argue that technically I've taught you what that graph looks like this year. Or you can think about an XY chart. Think about, if I put an X in, is it possible to get more than one Y out? Those are your options of how you can think about this. You say it is a function. Why do you say that?
Because it has to be a parabola.
Okay. X squared, guys. This is where I'm going to argue. We spent a whole chapter first semester. If a graph is y equals x squared, that is a parabola. Y equals x squared is a right side up parabola. The plus 2 makes it go up 2. I've taught you that. You know that. Whether you choose to remember, it's a whole other story. But does a parabola pass the vertical line test? It does. Okay. So this is a function. If you can't come up with the fact that that's a parabola, then take an x in. If I put, say, 3 in for x, can I get more than one answer out? Square 3, you add a number. Can I get more than one answer out? No. But another, you know, that's the thought process you have to think about there. Okay. The notes I'm looking at, I skipped, and this is because I want to make sure we get through a little bit of everything. I skipped D and E and went straight to F. Is that because there aren't any like D and E in the homework? I'm trying to remember. I'm thinking maybe that's why I skipped D and E, to save us a little bit of time, and there's not any like that in the homework. So let's go try F. If we have time at the end, I might come back to D or E. How's that? Let's see. I'll just zoom in on F. Okay. Steps have not changed. Step 1. Switch. So instead of y equals, I'm going to say x equals. Instead of 8x cubed, I'm going to say 8y cubed. And then minus 1. Step 2. Solve for y. It's 8y cubed minus 1. It's my first step to getting y by itself. Okay, if it's minus 1, let's add 1. We add 1 on one side. We add 1 on the other side. What is x plus 1? X plus 1? What is 8y cubed minus 1 plus 1? 8y cubed. I didn't flip it this time. Oh well, I'll flip it next step. Is y isolated? Is it by itself? Almost. How do I get, what's the next step to get y by itself? Yeah, if it's 8 times y cubed, divide by 8. If I divide one side by 8, divide the other side by 8. Okay. 8y cubed divided by 8 becomes y cubed. I'm going to treat this one differently this time. X plus 1 divided by 8. I'm actually going to leave it as x plus 1 divided by 8. Just because there's still one more step and how that works out. How do I get it to be y equals? What's that last step? Yeah, if it's a cubed, we're going to take a cube root. We cube the left. Cube root the left. We cube root the right. What is the cube root of y cubed? Y. They cancel, the whole design is they cancel each other out. What is the cube root of x plus 1 over 8? Okay, so you could say it's the cube root of x plus 1 over 8, all that under the radical. Does Math Excel like that? Maybe not. Because, what do I know about 8? Yeah. Blue papers? We're not really using them a whole lot right now, are they? Are we? But are they still relevant? Yeah. The cube root of 8 is 2. So you can take the cube root of just the denominator and not the numerator, which means I can write this as the cube root of x plus 1 over a regular 2. So can you see how I made it obvious that my radical is only on top? Okay. Now, just because I want to make you guys think about it. When we take a square root of both sides, what do we have to put in front of that right side? Plus or minus. I just took a cube root. Do I put the plus or minus? No. When's the only time I use the plus or minus? Even roots. So square roots, fourth roots, sixth roots. Okay. Just a friendly reminder. So, to write this in final form, I'm going to write f inverse of x equals the cube root of x plus 1 all over 2. Is it a function?
Yes.
Why are you saying yes?
Because there's not a plus or minus.
Okay.
So if you put in one value, if you cube that number, add 1 divided by 2, you probably won't get the same value coming out.
Okay. So, yeah, the idea is it's a good shortcut. There's no plus or minus. Okay. I'm trying to think if there's other places that would happen that would, cancel out being a function, but try a couple of numbers, If I put in, -1, or if I put in 0, or if I put in, say, 7, or, try some numbers. But I don't think you can't get the same thing. So, is it a function? Yeah. Do you guys know what that graph looks like? No. I don't believe we've talked about what a cube root graph looks like. Might we? I think we might talk about what a cube root graph looks like tomorrow. But at this point, do I expect you know it? Nope. Okay. You got the idea of finding inverses. This is a standard that we need to make sure we have a grasp on. So, and it does go back to Algebra 1. Don't know how much you did it back then, but. Okay. One last topic I want to make sure we get covered here is using composite functions, how composite functions and inverses relate, I guess. So, the idea here is if you're given a function and its inverse, or if you're given a function and you find its inverse, okay? So if you have a function and its inverse, then when you compose them, remember that fog and Goff stuff? So if you compose and do f inverse composed with f of x, it will equal x if they are inverses of each other. Same is true for the other way. If you compose in the other form and do f composed with f inverse of x, it will equal x. And this is if they are inverses. So essentially what this is this is our way that we can prove a function and an inverse are truly inverses of each other, because we can use these compositions. And that's what we're going to do here. So notice right here, f inverse composed with f of x equals x, and f composed with f inverse of x equals x. So, with that in mind, I just want to kind of show you how this works. It's broken up kind of into the steps, part A, B, C. Part A, well, we can't talk about, show how a function and its inverse are truly inverses if we don't know the inverse. So, just what we've been doing. Part A is find the inverse. We're given that f of x equals f of x equals 5 minus 2x. Find the inverse. How am I going to find that inverse? We just did this on the previous 4 problems. Step 1. Switch. Switch what? Switch X and Y. Teeny catch. I don't have a Y. Where's my Y? F of X is Y, yes? F of X and Y are interchangeable as long as it's Y equals. So you can think of this as Y equals 5 minus 2x to get started. Will that work for you? So when you take, if it's Y equals 5 minus 2x, step 1 is to switch. So what does it switch to be? X equals 5 minus 2y. How do you solve for y? Okay, subtract 5. Since it's a positive 5, I'm going to subtract 5. X minus 5 is x minus 5. 5 minus 5 cancels, and I have negative 2y. Now, how do I get y by itself? Divide by negative 2. Now, it's x minus 5 divided by negative 2. I'm going to leave it in that form for the purpose of when we do our compositions, it'll make life easier. Okay? So, my negative 2's cancel. I have y equals x minus 5 divided by negative 2. I'm content with that form. Technically, some people would argue, well, you can't leave a negative in the denominator. And if you can't leave a negative in the denominator, that just means you change all the signs. You multiply everything in the top and bottom by a negative 1, and that's changing all the signs. Okay? I'm perfectly fine with leaving it as is. Okay, so if I write this in proper notation, f inverse of x is equal to x minus 5 over negative 2. So same thing we did up above. That was part A. Part B wants us to find f inverse composed with f of x. Now, if I say we already know the answer to this, did you catch what the answer should be? X. When you do compose, either way, doesn't matter which way, but when you compose an inverse and its function or a function and its inverse, it will always equal x, or will always equal whatever's being plugged in. So, let's try it and prove it, or show it. So, f inverse composed with f of x is f inverse of f of x. Do you remember how this works? You have to go all the way back to last week. Okay, look at the inside. What is my inside? My inside is f of x. Do we have an f of x? We were given f of x, yes? So we're going to take that f of x and we're going to plug it into f inverse. You can do that all at once. Or if you want, write it out first. So f of x is 5 minus 2x. And so, f of x is 5 minus 2x. We're going to take 5 minus 2x and put it into the inverse. F goes into f inverse. So that means 5 minus 2x goes into what? This fraction down here, right? So f inverse says it's x minus 5 divided by negative 2. So that means I'm going to do something minus 5 divided by negative 2. what am I putting in for something? What am I putting in for x? What are we putting in here? 5 minus 2x. So there's the f inverse I'm using, came from over there. 5 minus 2x is going in place of x. So that is me taking f and putting it into f inverse. Okay, do some cleanup and see what happens. Numerator. 5 minus 2x minus 5. 5 minus 5 is zip. So what am I left with? Minus 2x over negative 2. What is negative 2x divided by negative 2? X. Are you surprised? You shouldn't be. Okay? Here's the thing to watch out for. If it doesn't come out to be x, where did you make your mistake? Did you make your mistake in this part, or did you make your mistake back when you were finding the inverse? Okay? If you're ever asked to prove that two things are inverses, you have to do it both ways. You have to show f composed with f inverse and f inverse composed with f. Okay, one more. Let's try C. Now, let's see who has this figured out. F composed with f inverse of 2 this time. So last time it was f inverse composed with f of x. This time it's f composed with f inverse of 2. What's my final answer going to be? Okay, we hope it's 2. Why 2 in this problem? Because what's my input right here? I have a 2 here in the place where normally we'd have an x right here, yes? I have a 2. So you get whatever's there. So in this case, it was an x. So we got an x. This time it's a 2. So we should be getting 2. Let's show it. So f composed with f inverse of 2 means what? Okay, in which one? Okay, yeah, in the inverse in this case. So we're doing f of f inverse of 2 is how I'm going to write that out. So if I'm doing f of f inverse of 2, start with f inverse. F inverse of 2 means in f inverse, I'm going to plug 2 in. So what was f inverse? Okay. It was supposed to be x minus 5 over negative 2. It was supposed to be x minus 5 over negative 2. What am I going to say instead? Instead of x minus 5, 2 minus 5 over negative 2. So 2 minus 5 divided by negative 2. And that's because we're taking 2 and putting it into f inverse. What is 2 minus 5? 2 minus 5 is negative 3 over negative 2. Yes? What is a negative 3 divided by a negative 2? Positive. I'm going to still say 3 over 2, but it is a positive 3/2. Now, what was that mean? What was I doing there? That was just me taking 2 and putting it into the inverse. As a result, I got 3/2. What do I do with that 3/2? It's going into f. What was f? 5 minus 2x. So that means I'm going to do 5 minus 2 times 3/2. Okay, don't let the fraction scare you. Oops, sorry. Got a little crazy there. What is 2 times 3/2? You can think of the 2 as a fraction by saying 2 over 1. 2 on top and a 2 on bottom cross cancel, and so that becomes 3. 3's on top, so it's 3. So now I have 5 minus 3, which happens to be 2. Is that what I expected my answer to be? Yeah, that was the input. So when you put a function and its inverse together, it will also be your output. Okay. You guys want 10 minutes? 9 minutes now? Okay. Go ahead and take a peek at the homework. Get a few started. 6, 7 is due tomorrow.